drop me a message if you are in. Those of you who have my WhatsApp, that is not happening today, so we're going to live chat only. I've got a double screen going. I will check in with you in just a moment. So I'm just going to mute myself and we're just going to wait for the rest of the people. Alright guys, so we're just going to give it 5 more minutes. There's only about 30 of you in. So we're just going to wait a little bit just to see. And then we will take it from there. Those of you who don't have the paper, we're doing Gauteng's trial exam. So this paper Gauteng wrote now. And then we'll, obviously because it's a live stream, it will record and then I'll share the video link with you guys as well. Alright, so just give it 5 more minutes and we'll have a go at it. Alright, it looks like we have started settling a little bit in terms of numbers. So just a couple of thumbs up if you guys can hear me. This is the first time we are attempting to do it this way. So I know that the stream is slower than, or the chat is delayed by a couple of minutes. So I just want to make sure that we all respect each other in the chat. I've got one or two moderators that's got an eye on the chat. So let's just make sure that we respect each other and that we give each other the opportunity of asking questions and learning from each other. So for those of you who don't know me, I am a teacher at PHA, and I teach physical sciences, and I have been doing teaching for a number of years. So I just want to make sure that we all like on the right track here and everybody's okay. So just give me a second. I am going to jump around just a little bit today, just so that you guys are aware. Yeah, this is my first rodeo in this thing. Okay, so it might take a while for me to just get used to how we're doing things. But we will take it one step at a time. Okay. Just give me a second to open the second screen for just in case. Dum, 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 dum. Right. Okay. So if we're ready to go, I did send the question paper through to the teachers and so forth. So, you know, you guys do have it. I'm going to try and get through the entire question paper. My plan is we're going to start with question 2, 3, and 4. And then I'm going to go to the organic chemistry for question 2, 3, and 4, if that's okay. Sorry, the short questions, the multiple choice questions for 2, 3, and 4. And then we will take it from there. And then we're going to go to rate of reactions and the dreaded equilibrium and acids and bases, and we'll have a look at those multiple choice questions, and then lastly we'll have a look at the electrochemistry questions. Okay, so I think without further ado, if everybody is ready, then let's get going with the question paper. Going right. Okay. Right, ladies and gentlemen, organic chemistry is the basis of your paper 2, guys. So I really do need you guys to make sure that for organic chemistry you try and ace as much of that question paper as possible. And yeah, okay, so I'm going to start with question 2, and I'm going to do question 2 the way in which I approach question 2. So if you have different processes, don't necessarily follow my process because I say it is the way that I do it. I just want to give you guys some guidance as to how I would look at it. Alright, so I always start by looking at the table first for question 2. Seeing this table is quite normal. They tend to ask it this way, so although I cannot guarantee you that this is how the question is going to be asked, I can with quite strong certainty say that there's a high likelihood that you'll get a table like this in question 2. So I always start by analyzing it first and then I go to the questions. So I firstly see that here I've got that carbon with a double bond oxygen, which means this is either an aldehyde or a ketone. And if I look at the carbon that is attached to this double bond, we see that there's 2 carbons either side, which means this guy here ends up being a ketone. And remember, you are allowed to write on your question paper, so things like this where you make notes is always a good idea for you. No one's going to take your question paper in to market, so use your question paper and make notes for yourself. Alright, so that's a ketone. Then here, if I look at it, there's no double bonds, and all the carbons seem to have exactly the right amount of hydrogens. What I do pick up here, that there is a bromine and a chlorine attached, so this would be a haloalkane. You could also call it an alkyl halide, but I prefer the term haloalkane. Right, then here we see our ever famous COOH group, and that COOH group means that this is a carboxylic acid. Then we see we've got ethyne here, which means we've got an alkyne, so we've got a triple bond. And here, no triple bonds, no double bonds between carbons. However, we do have this OH group here on that carbon, so this would obviously therefore be an alcohol. Alright, okay, so now they ask us certain questions, and sometimes the analysis we've done right in the beginning helps us out with these questions, and then other times, unfortunately, we have to go and dive it a little bit deeper. But let's have a look. So the first question is, name the homologous series to which each of these compounds belong. And that's generally what I do right off the bat, is I make sure I know which homologous series I'm dealing with. So A, we said, was a ketone, and C, we said, was a haloalkane. Alright, like I say, you could also call it, this is not my favorite terminology, but completely accepted, an alkyl halide. Both of these are completely acceptable terminologies. Alright, straightforward level 2 question, I think, if I had to analyze it. Write down the IUPAC name of compound C. Right, so whenever I do IUPAC naming, I always start by finding the longest carbon chain. And you need to be careful because it's not always straight. So 1, 2, 3, 4, 5, there's a little crick in it. Or I could go 1, 2, 3, 4, and 5 down. But either way, I've got 5 carbons. And 5 carbons means I'm dealing with pent. Alright, as I've said, there are no double or triple bonds between any of the carbons, so pentan, right? And normally if you had, let's say they were asking for this one, then it would be pentan wherever the alcohol is ol. But because we've got the halides, obviously the halides get named as substituents, so this is simply going to be a pentane. Now we've got to decide from which side do we count. Now you always try and get firstly the functional group on the lowest possible carbon. So for example, this alcohol, I wouldn't go from left to right, but from right to left, because then I get that OH group on a lower carbon. However, here we don't have that functional group that we have to number. So here we're going to try and get the total of the substituents on the lowest possible numbers. Alright, so 1, 2, 3, 4. So we're going to have 1 bromo, 2, 3 chloro, 4 ethyl. 4 methyl. If we counted from the other direction, then it would be 1, 1, 2, so 2 methyl, 3 chloro, that would stay, 4, 5 bromo. And I hope you guys can see that 1 plus 3 plus 4 gives me 8, where 2 plus 3 plus 5 gives me 10. Right, so you try and add the numbers together and see which of those totals give you the lowest possible number, which means we are going to number this one, or name it at the very least, from left to right and not from right to left. So my substituents is, there's a 1 bromo, this isn't my final name, this is just me thinking, 3 chloro, and 4 methyl. Alright, and when I write the substituents on the front, then I am expected to write the substituents in alphabetical order, which happens to be in the order that they are. So I'm just going to switch to a separate piece of paper. You guys can all see my kitchen table underneath where I'm working. So this guy's name, what's this, 2.2, is going to be 1 bromo, 3 chloro, 4 methyl pentane. And now I hope you guys can see there's a dash before and after every single number. If I had more than one number, there would be commas between the numbers. So I'm going to say that again because that is super important. There is a dash before and after each number, and if I had more than one number in a row, there would be a comma in between each of the numbers. That is incredibly important to remember. It's very, very basic organic chemistry. It's not something where you guys should be losing marks at. All right, I hope that is okay for everybody. Okay, then for 2.3, write down the letter. Please note the letter, okay, not the name of the compound, not anything else. Write down the letter. So be careful that you guys don't misread that. But anyway, here we go. Write down the letter for the compound that has a carbonyl group. And so carbonyl, we are looking for C double bond O. That means we are looking for the ketone in this situation, which is A. Right. So write down the letter of the one with a carbonyl group. They are looking for A. Just looking at mark allocations, 2.1.1, right or wrong, 2.1.2, right or wrong, and 2.3, right or wrong. For the 3 marks, the mark allocation, let me just grab a red pen, would go for, so if you got the whole name correct from the word go, then obviously it's 3 marks, okay? If you didn't write the substituents, but you wrote pentane, they would give you a mark for that. And then, if you got all the substituents correct, there we go, the names of the substituents correct, that is another mark. And your last mark goes for the correct numbers as well as the correct order of each of these. These one of those situations where it's just much easier to know to get it right every single time, because then you don't have to worry about how many marks out of 3 you're getting. Okay, now we go to 2.4. Write down, and very important guys, the structural formula, not the name, okay, the structural formula. So write down the structural formula of the functional isomer of compound A. Right, we've already said compound A is a ketone. We are looking for a functional isomer, which means we are looking for an aldehyde, which means functional isomer compound. Right, so functional isomer means it has to have the same molecular formula, so the same number of carbons, the same number of hydrogens, and in this case the same number of oxygens, just the one, right? And we want to move that oxygen to a primary or a outside, a terminal carbon. All right, so 2.4.1. Compound A has 1, 2, 3, 4 carbons. So I would simply start by putting all 4 my carbons down. We know that we have to move the double bond oxygen to the terminal carbon. You can either put it in the front or in the back, really doesn't matter. And now guys, if you haven't been in my classes, I always count to 4. It is so easy when doing structural formulae to, by accident, not have the right number of hydrogens on each carbon, and that is very dangerous. So, because then the whole thing is wrong. You've done all this work and then you lose silly marks because you didn't take the time to count to 4. Alright, so we're going to count to 4. We're going to go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. That hydrogen can go up or down or to the side, doesn't really matter. And now everywhere where I put a line, I put a hydrogen. There we go. Alright, so if you have the functional group correct, that is 1 mark, and the rest of the structure is the second mark. Again, it's a lot easier with these simpler questions to make sure you get it right every single time. Right. (2.4.2) Write down an ester, the structural formula of an ester, with the same molecular formula as compound D. That is a very fancy way, well, no, it's actually quite a nice simple way to ask for a functional isomer of this. Right, so you only have 2 carbons, so that means that one of those carbons needs to be on the part of the ester that comes from the alcohol, and the other carbon needs to be on the part of the ester that came from the carboxylic acid. Alright, and then again I make sure I count to 4, so 1, 2, 3, 4. Oxygen, 2 bonds, that's fine. Carbon, 1, 2, 3, and 4. Right, and there is our esters functional. Sorry, there is the functional isomer effectively of compound D, the ester. Alright, and then 2.4.3, a tertiary alcohol of compound F, meaning take this compound and turn it into a tertiary alcohol. Now, the one that is on the table is a secondary alcohol. I just want to quickly stop there and remind you that it is secondary because the carbon that the hydroxyl group is attached to is attached directly to 2 other carbons. So when they ask us for tertiary alcohol, that means that we have to have a alcohol that is pretty branched. Okay, so 1, 2, 3, 4 carbons. The easiest way I found to do these is to put your carbon and attach your OH group. Can you all see that my OH group is separate? There's a bond between the O and a bond between the H. Please don't be lazy and write OH, because that would be wrong. Okay, now I need to attach 3 carbons to this carbon so that I have a tertiary alcohol. So we're going to go 1 carbon, 2 carbon, 3 carbon. Now, in order to make sure that I have the basics of the structure, I go back to my picture and I go, okay, how many carbons do I need? 1, 2, 3, 4. How many carbons do I have in my picture? 1, 2, 3, 4. I'm all set. Now I just need to count to 4 and add the hydrogen. So 1, 2, 3, 4. That one's all sorted. This one down here, 1, 2, 3, 4. That one, 1, 2, 3, 4. And I add my hydrogens. The more you do this, the quicker and easier the process becomes. I know it sounds tedious, but it just means that you never make a mistake with any of these. All right. Next question. 2.5. Explain why compound A is not an unsaturated hydrocarbon. All right. So if we look at compound A, you guys will remember that unsaturated hydrocarbon means that there are double or triple bonds, so multiple bonds, between carbon atoms. And the word hydrocarbon means that the compound has got carbons and hydrogens only. All right? So I would start by saying, if you look at A, there are no multiple bonds. Apologies for the puppies, guys, I am at home. No multiple bonds between carbon atoms. Okay? So that's the one reason why it's not unsaturated. This is a saturated compound. And secondly, there is not only carbon and hydrogen atoms in the compound. Okay. So if I look at the marking memo in front of me, the 1 mark goes for saying that there are no multiple bonds, and the other mark goes for indicating that it is not a hydrocarbon. All right. If they were only worried about the hydrocarbon part, then they probably would have asked. They would have asked it as, why is that not a saturated hydrocarbon? Okay. Right, almost there for question 2. We've got 2.6, 2.7, and 2.8 left to go. 2.6, write down, again, a letter in the table. Alright, so we are looking for an unsaturated. Unsaturated meaning we need double or triple bonds. It's a hydrocarbon. That means we are looking for an alkene, or we are looking for an alkyne in that table. Alright, and lo and behold, ethyne stands out quite quickly. And if I look at the table, I really don't see any of the others doing possibly that. B, if I look at it, is a branched. Where are you going? Yes, it's a branched alkane as well. Okay, if you're not quite sure about how to deal with that, I would draw out the entire structural formula of that one. Alright, so an unsaturated hydrocarbon, there's an alkene, so they are looking for, it is number E. Again, right or wrong, 1 mark. Write down the letter of the compound with a general formula of CnH2nO. Right, now, you guys must know your general formulas, alright? It saves you so much time, energy, and effort because you could go and count out all of these, obviously only worrying about the compounds that have an O in it. But there are 2 compounds with this general formula, so you are either looking for an aldehyde or you are looking for a ketone in the table, and we know that the ketone is letter A. Alright, we've had it a couple of times. Alright, I hope that is okay for everybody. Again, if I look at this question and I compare it to what we had in the paper 1 for the same year and the same province, this is a so far much simpler question than what we had in the other paper. Alright, so 2.7, using molecular formula, write down a balanced chemical equation for the combustion of compound B. Alright, so now we're going to go to compound B and we're going to go, right, how many carbons? 1, 2, 3, 4, 5. So we've got 5 carbons. 3, 4, plus 3 is 7, plus 2 is 9, plus 3 is 12. And that makes sense, because that is 5 times 2 plus 2. So this is a branched alkane. Alright, so I'm going to write this out. Now, some of you will feel very confident in balancing chemical equations, and some of you will feel significantly not. I need you guys in grade 12 to realize that this will be the, probably, not guaranteed, but most likely, this will be the only chemical equation that you will have to write out and balance. Most of the others, if you think about the organic reactions, most of them are naturally balanced as we go along. So, if you write down just the alkane, the oxygen, carbon dioxide, and water, this is worth 2 marks. Mark allocation goes 1 mark for the reactants and 1 mark for the products. So if you can just write down the correct reactants and the correct products, you have 2 out of the 3 marks. And here's now where it becomes important to know yourself and know your own ability and to understand your timing. If you can easily balance, then you balance. If balancing stresses you out, it is not worth you, most likely in question 2, 3, or 4, stressing yourself out. Okay? You can always go back and balance it later. Don't leave the question out just because you struggle to balance. Okay? When I balance organic, I always start with balancing the carbon dioxides from the number of carbons in my alkane. And then, other color, Mrs. Tucker, I see your question. I do think you are absolutely right. We'll quickly deal with that as well. Then I balance my waters from using the number of hydrogens in the alkane. So 12, I'm going to divide 12 by 2, which means I need 6 waters here. And then lastly, which color is going to work? Oh, I've got a nice yellow. Let's hope it works nicely. Then I go backwards and I balance my oxygens. Alright, so 5 times 2 means that carbon dioxide has 10 oxygens. 6 times 1 means that that water molecule has 6 oxygens. I add the 2 together and I need to have 16 oxygens I have 16 oxygens on the right, which means I need 16 oxygens on the left. There's that 2. 16 divided by 2 means that I need 8 oxygens. Alright, I know sometimes you need to add a 2 here. That's if this oxygen number here is an uneven number. Alright, so your final answer here is going to be C5H12 plus 8O2 gives me 5 carbon dioxides and 6 water molecules. Alright, relatively easy balancing. Your problem normally comes in if half of your hydrogens is an uneven number, because then your oxygens struggle, but this is a nice one. Alright, I'm quickly going to deal with question 2.8 of this question paper, and then what we're going to do is just quickly look at how to deal with esterification from an alcohol and a carboxylic acid, both the structural formula as well as then the naming of that, okay? Because sometimes you guys seem to struggle with that. All right, 2.8 on the next page. I don't know if they just couldn't fit it in nicely, or, you know, I probably would have tried to do this formatting better, but anyway. A compound is analyzed and found to have an empirical formula of CH2O. All right, grade 10 work this question. And then they say it has a molecular mass of 150 grams per mole, and you need to determine its molecular formula. Alright, so you need to think about it as how many empirical formulas do I need to get to the molecular mass of that compound. And you can only do that if you first establish what the molecular mass of that empirical formula is. So 12 plus 2 plus 16, that's 14, 20, 30. Alright, don't tell the math people. I'd regularly put 2 equal signs in the same line. Alright, now the question becomes, how many of these, which are each 30 grams per mole, do I need to get to 150? Sometimes there's a mark in it for showing the division. More often than not, there is not. Last time I checked, 15 divided by 3 was 5. If I'm wrong, please correct me. I do make silly mistakes every now and again. Now, some people do this and then think that's the answer. No, ladies and gentlemen, you are asked to write down the molecular formula of this compound. So you actually do need to go and write out the entire molecular formula. Okay, it is a mistake that I sometimes see. I think the more emphasis we place on it, the better. And then you guys stop making that mistake. Alright, so just quickly to show you guys esterification, I am specifically choosing an alcohol and a carboxylic acid that have different carbons so that you can see how the whole thing fits together. Alright, so let's go for smaller ones. Propan-1-ol plus butanoic acid. Alright, so we are saying that we are performing an esterification reaction. We are using propan-1-ol and butanoic acid. For your information, guys, I don't know if you've been told this. There are people from other schools in here, so I just want to make sure that everybody knows we're on the same page. You only have to deal in grade 12 with primary alcohols with esterification. Okay, that doesn't mean that they don't exist in other ways, but in grade 12 we only have to deal with them as primary alcohols. Okay, so if I look at propan-1-ol, prop 3, so propan-1-ol. Right, then butanoic acid, there's the acid part. Gemma, I see your question. I will go back to it in a second. I've got you. Alright, so bute means 4. 1, 2, 3, and 4. Alright, now, when I form esterification, I heat gently my alcohol and my carboxylic acid in the presence of concentrated sulfuric acid, and I do that to dehydrate. I dehydrate, I remove water. So carboxylic acid gives up its acid part, and the alcohol is really nice and gives up its OH, right? Then there where I'm creating those two empty bits, they combine. So I have the propanol part, then this oxygen bonds there, and then I have my butanoic part, 1, 2, 3, and 4. Alright, now, the thing we find with a lot of learners is that they do this, and then they stop. And then you don't get full marks, because you forgot about the thing you pulled off, dehydrating, right? And then what some of you do, instead of writing the structural formula of water, yes, my voice is going up because I see this a lot. Instead of writing the structural formula of water, you go H2O, all right? So it sounds like an incredibly silly little thing, right? But that part there costs you marks, all right? And it is a silly thing to do, all right? So here is our ester. We took propan-1-ol, reacted it with butanoic acid. We heated it gently in a water bath because these two guys are flammable. We added concentrated sulfuric acid as a catalyst because it dehydrates. And then we got as a product propyl, which comes from propanol. Then we've got the part that came from butanoic acid, butanoate. And for you guys in grade 12, that O8 is how you recognize that it is an ester. All right, in the chat, Jamie asked, why do I, when I'm working with the empirical formula to molecular formula, why don't I just add the 5 in the front? The 5 in the front is a stoichiometric ratio, meaning that we use 5s or 2s or whatever in the front, just like here, in order to balance the chemical equation. When we balance a chemical equation, what we are assuming is that that is the complete and correct molecular formula for that compound. They are asking you for the molecular formula of this thing. So they're not asking you to give you 5 empirical formulas. They're asking you for the actual molecular formula. That is why you take the 5 at the bottom, multiplied by 1, 2, and 1, rather than putting it in the front, because then you're saying I have 5 of these things, which is not completely correct in terms of this molecular formula. So big numbers in the front go for balancing. Little numbers at the bottom are part of the molecular formula. All right, good question there. All right, guys, so that is question number 2. Now we go on to question number 3. Question number 3 is our boiling point question. I really like the boiling point question. I think that it's generally straightforward. The hardest they can make it is to add a graph, and depending on how mean they want to be, you end up with graphs of weird things. But anyway, so we have 4 organic compounds, A, B, C, and D. Very important, they all have different functional groups. Ladies and gentlemen, that is the best news ever, because it means that we already know that the actual intermolecular force is going to be the definitive factor that influences the strength of the intermolecular force. So the type of intermolecular force is probably going to be the main thing that we talk about here. And I always find that a lot easier than having to deal with compounds that increase in molecular mass, compounds that increase in carbon chain length, or compounds that are different in terms of branching. All right. Define the term boiling point, ladies and gentlemen. I've said this once, I will probably say it a million more times in my lifetime. Boiling point is a temperature. It is not the point at. Boiling point is a temperature. Please, pretty please with all cherries on top. Okay? Boiling point and melting point are temperatures. And the key words here is you want it's where the vapor pressure is equal to atmospheric pressure. Right, instead of saying atmospheric pressure, sometimes, and now I say this very guardedly, sometimes they are quite happy for you to talk about the external pressure. I would be careful in saying that. Okay. So I would say it is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. Okay. You have this investigation, independent variable. What is the thing that you are changing? The compounds have different functional groups. Ladies and gentlemen, they spelt it out for you. It is the functional group of the compound. Other possibilities, you could have said that obviously different functional groups means they are different homologous series. And then the one I would be very careful of to say, because it's not specifically stated in the question, but I suppose you could get away with saying the different type of intermolecular force. All right, I would be careful of that one. So the functional group of the compound or the homologous series, one of those two. Explain the trend in the boiling points from A, B, and C. All right, 4 points. Now, we can see that the boiling point of A is less than, B is less than C. All right. So, if we look, A very, very clearly is an alkane. Right. So, we have an alkane, which means we are dealing with London forces. Right. Here we have that 4-mole group, right? Not a carbonyl group, a 4-mole group, which means this is an aldehyde, right? Here we've got that carbonyl group there. You see it hidden. Ooh. Yes, Crystal. Sorry, you guys just need to remember when I go back, there is a definite lag between when I stream and when I see your comments. Okay, so every now and again, it is going to come through later. Crystal, yeah, we as teachers and as markers, we've often had that specific question that you are asking. You need to realize that different compounds, like Mrs. Tucker says, could mean that it's pentane, butane, propane, or they have different functional groups, or they all have different branches. Okay, so with these types of questions, be very careful to just say it's a different compound. Okay, I actually don't think there has ever been a situation in which they would accept it because it is so vague. All right, but it is a good question. Why do I say it's a good question? Because I regularly see that mistake. All right. Right. So we said A is an alkane, so we have London forces. B is an aldehyde, which means dipole. And C, there's that little carbonyl group very much hidden. So this is a ketone, which is also dipole. All right. So when I answer this question, I definitely would start by explaining why A has the lowest boiling point. Okay? Because it means you're eliminating one, and then you only have to deal with why is B and C different. So I would say, which question are we at? 3.3. Okay, so I would say that A is an alkane with London intermolecular forces. And ladies and gentlemen, very, very, very important. If you have not written out the word intermolecular forces, you cannot use IMF. Okay? 1 year they accept it, next year they don't. I am telling you now, if you just start with London IMF, you are putting yourself up for getting 0 out of 4, even though you have answered the question correctly all the way through. Do not do that to yourself. Okay. Then B is an aldehyde, and C is a ketone, both with dipole IMF. Okay, which now means you can say London IMF is weaker than dipole IMF. Okay. So London forces are weaker than dipole forces. Alright, so now I have eliminated A from the drama. Okay, now I need to argue why B and C would have different boiling points. So, little known fact, ketones, because the, let me find it, okay, because the polarity is in the middle of the compound, your compound is longer and it creates a bigger area, one on either side, in which this dipole here can create induced dipoles on that side, where with the aldehyde it's on the one side, so it can only create induced dipoles right next to it. All right, so it's not particularly part of the curriculum, but I have seen it being asked more and more and more. All right, so if I look at the mark allocation and I look at the 4 marks, to go into so much detail for 4 marks, I think is too much. Okay? I would simply at this point be able to go, okay, London forces are weaker than dipole forces, and then say the IMF for compound B is weaker than the IMF for compound C. Okay? Why can I say that? Boiling points. Okay. If it was a 5, 6, maybe 7 mark question, then I would go into detail as to why. Right. Now, ever famous, I always state this. I always say, stronger intermolecular forces require more energy. And now I can hear every single PHA learner screaming and shouting at the top of their lungs to overcome the forces. Ladies and gentlemen, you cannot say you break forces. You don't break forces, and more than that, you are not breaking bonds when something is boiling or melting. Alright, Josh, yes. The second something has a higher boiling point than something else. So Josh's question is, do I have to specify the one is stronger than the other one because of the IMF? Well, it's because the boiling point, the one boiling point is higher than the other boiling point, and therefore I know that the intermolecular forces are stronger. Alright, so Darwin's questions. Do you have to write out intermolecular force and then you can write IMF? Yes. You cannot just write out IMF. You cannot just use the acronym IMF. You must write out intermolecular force first. Okay? The reason why I do that is because the words intermolecular force take very long to say. Guys, give me a second. Sorry, I just asked for something warm to drink here in the background. Crystal wants to know whether B or C has the longer chain. It is relatively irrelevant. They both have the same length of chain because they have the same molar mass. So they have the same number of carbons, the same number of hydrogens, and the same number of oxygens. It's not about the carbon length. It's about where you find the oxygen. Okay, so I'm quickly going to zoom in. There we go. Right, so what happens is this oxygen is the dipole, and dipoles induce other dipoles, right? So this oxygen creates induced dipoles going down. The further away from the oxygen it is, the weaker the dipoles going down the chain is. Where with a ketone, the dipole is smack bang in the middle of the compound. And so this dipole equally strongly creates induced dipoles there and equally strongly there. Right. So that means that the induced dipoles in a ketone are much stronger because they are on both sides of the oxygen, where the induced dipoles for an aldehyde is only on one side of the oxygen. Like I say, I haven't actually seen that specifically mentioned in the curriculum. I know that because I had a bit of a misconception one day for myself that I then went and dealt with. Sorry about the kettle, guys. Alright. There we go. Almost done with this part. So you overcome the intermolecular forces, which means that the compounds have higher boiling points. Alright. Never, ever, 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 ever break bonds. You cannot break forces. You do not break bonds when you are changing the phase of a compound. Okay. 3.4 is a very typical question. Vapor pressure. Remember, vapor pressure and boiling point are inversely proportional. Not really, meaning if something has a high boiling point, it will have a low vapor pressure, right? Because it takes a lot of energy to make the vapor happen. So the question is, which will have the lowest vapor pressure? So you are looking for which one of the two has the higher boiling point. Okay? So if you look at the table, C, D has the higher boiling point, right? So D, and this argument that I just made happens to be the give a reason for your answer. So D has a higher boiling point than C. Right, just want to double check. Yeah, okay. Okay, cool. Not a bad question so far. Write down the following. So you can see they're 1 mark each, so it's either right or wrong. Write down the phase of compound A at room temperature. Room temperature 25-ish, oh my goodness, degrees Celsius, 20-25 degrees Celsius, around about there. So A boils at 36, right? Which means a temperature lower than 36, let's go 20, it is a liquid. At 36,1, it turns into a gas, and any temperature above 36, let's say 38 degrees, it is a gas. All right, this little trick that I just wrote down over here is easier to deal with when you have things that are at positive temperatures, okay? But this little trick of writing down, picking any two temperatures either side and writing down the two phases either side of its boiling point, and obviously if it's melting point, then this is going to be solid and liquid. This little trick here really, really helps when you've got negative boiling or melting points. Okay, so phase of A at room temperature, which is below the 36, it will be a liquid. Right, the structural formula of the functional group of B, we said B is an aldehyde, so it is the structural formula of the formal group that they are looking for. Right, one more question in boiling points to go. We're doing good, I think. IUPAC name of C. There's C. We've already said it's a ketone. Now, I really struggle to be able to work straight from a condensed structural formula. That is a very personal thing. There are some of my students that prefer condensed structural formulas. I am really not one of them. So what I do is I always write it out. So that first carbon has 3 hydrogens attached to it. That carbon there. The next carbon is the one with the double bond oxygen on it. The next carbon has 2 hydrogens attached to it. And the last carbon has 3 hydrogens attached to it. Alright, I find it a lot easier to deal with naming once I have a complete structural formula. So, 1, 2, 3, 4, this is bute. There's only single bonds between all the carbons, so butane. There is a double bond O ketone, so I'm looking for the functional group one. 1, 2 versus 1, 2, 3, so it's butane 2 one. Now I know some of you are going to come out and ask, can I write 2 butanone? Technically speaking, yes, but that is incredibly dangerous to do because this one works nice and easily because there are no substituents. So be very careful of putting the number for the functional group in the front. Okay, it is incredibly dangerous. Darwin's asking if the live stream is going to be posted when it's finished. Because it's on YouTube, it automatically saves it as a video, and you can then go back onto the channel and watch it. I will share the live stream link on exactly the same places as I shared. Sorry, let me try that again. I will share the link for the video on exactly the same place as I shared the live streaming one. The reason why we're doing it on YouTube is so that we have that function of having it auto record basically, as well as being able to deal with more people in the chat and in the group. The only problem is that there is more of a delay. So, tit for tat, unless you guys can give me a better way of running 300 people in the same thing, then yeah. Okay, cool. So that is question 3. One more organic question to go, and then I'm going to look at the multiple choice questions for organic chemistry, and then we are going to go to the middle part of the question. I never do it as the middle part of the question. I always do it as the first part of the question because I like stoichiometry. But that's just me. Alright. So question 4. Almost always, I'm always careful to say always, but question 4 is almost always a reaction, an organic reaction question. This one looks different than what we're used to. We are used to seeing a flow diagram. I don't know, I sometimes think you guys get panicked and stressed about the flow diagram. I don't know why, but yes. So here we have a flow diagram. This is quite an interesting question. I remember seeing this one. Quite funny. 4 bottles containing organic compounds are found in a laboratory. We've got a primary alcohol, a secondary alcohol, propene, and propanoic acid. Right. I'm wondering if one of these is going to be propanol. Right. Write down the type of reaction that occurs when each of the following reactants are used. Bottle A, primary alcohol, and bottle D is propanoic acid. that can only be esterification. I always think everybody lost their eyes when they decided on this name. Okay. Now, this one is a relatively straightforward question, but identify the type of reaction means that you have quite broad abilities when you are dealing with addition and elimination and substitution reactions if they come up. Okay, anyway, so 1.2, bromine water and bottle C. C is an alkene. So if I start with an alkene, then the chances are I have got an addition reaction. Now, obviously, they say identify the type. So addition, completely an acceptable answer. I could also write that this is a halogenation because adding bromine means I'm adding halogens only. And lately I have seen that you could also, instead of writing halogenation, write the specific halogenation you are adding. So my brain, yes, bromination would also be an acceptable answer. I'm going to be very honest with you guys. I would go for addition every single time, okay? Because my brain can get to that answer quickly. Christopher asked, do esterification reactions always use primary alcohols? In grade 12 chemistry, esterifications always use primary alcohols, okay? I am clarifying, right? So that you guys don't think when you get to university that I've lied to you your entire lives. In grade 12, in the CAPS curriculum, all esterification reactions use primary alcohols. Okay. Last type of reaction, bottle B, a secondary alcohol and concentrated sulfuric acid. Okay, I always say to my kids, this works with the flow diagrams better, but anyway, if you start with an alkene, it is almost always an addition reaction. If you end your reaction with an alkene, it is almost always, again, please here, I'm clarifying, it is almost always an elimination reaction. If there is neither an alkene as the product or as the reactant, the chances are you are dealing with substitution reactions. Then obviously you have your special ones, esterification and cracking and oxidation or the combustion. All right. But in this case, it makes it a little bit harder because they give you, I'm starting with an alcohol and I'm adding concentrated sulfuric acid. So now it is up to you to know whether or not this concentrated sulfuric acid is a reaction condition for elimination or whether it is a reaction condition for a substitution reaction. Now, if we're honest, the chances are that if they wanted you to do a substitution reaction, they wouldn't necessarily just give you the reaction condition. They would rather tell you what other substance you are adding in order to do the substitution, right? So my gut feel went to elimination instantly because there was no halide something that the alcohol could react with and then interconvert. But again, it is important to know your reaction conditions. I do think that this would be classified as a level 2 question, although it is a harder level 2 question because you are expected to kind of work backwards from your reaction conditions. So this is an elimination reaction. All right, you've got an alcohol, so obviously you are dehydrating. I hope that thinking makes sense to you. Like I say, harder level 2 question. Okay. Give the structural formula of alcohol B if the alcohol has the prefix of hex. Oh my dear goodness. Hex means 6 carbons. 2, 3, 4, 5, 6. Secondary alcohol means it could go on any of the middle carbons, okay? Why would I struggle? I'm going to put it on carbon number 2. They're not asking me for the name. They're saying structural formula. So I was like, okay, cool. Let's put it on the quickest, easiest available carbon. I count to 4. And I add my hydrogens. Okay. So I personally think that that is a very easy question. Okay. Use structural formula. Represent the chemical equation for the formation of the ester called butyl propanoate. Okay. It happens to be almost the same as the one I did in just a little bit earlier, but I always think that esterification is good practice. Okay, so just as a side note, they are asking me to show the formation of oops, sorry guys. Butyl propanoate. Alright. Then, just going to point out, include IUPAC names for the reactants. Okay. Kid you not. Include IUPAC names for the reactants. That's why it's 6 marks. Normally this thing would be 4 or 5 marks. Alright. So, butyl comes from butan 1-ol, and propanoate comes from propanoic acid. Alright, so we have to go butyl, butanol, 1, 2, 3, 4. You will notice that whenever I'm doing esterification, I tend to write my OHs, so my alcohol group goes right by the carboxyl group. It just makes it easier in my brain to know where that oxygen needs to go. So propanoic acid, 1, 2, 3 for prop. Okay, so now I'm going to count to 4. And I'm going to add hydrogens all over the show. I know this is painful, especially when your carbon chains get longer and longer and longer, but I'm going to remind you that writing H's might be painful, but it's more painful to lose marks because you didn't write your H's. Naha! Alright, so I just want to make it very clear here quickly. Let me just grab a ruler that doesn't want to come off the table. That up there is my thinking. Alright? So, I would just think this and then go, here's the structural formula, and this thing is butan 1-ol. And this thing here is propanoic acid. Because remember, they asked for the IUPAC names of my reactants. Now, I know that it is not stated, but I am always super careful when I know that there is reaction conditions and I can write it on the arrow and it goes quite quickly, you know what? Maybe there's a mark in it, maybe there's not a mark in it. Who cares? It doesn't take me that long. I'm going to write it down. And then the structural formula of butyl propanoate. Butyl propanoate. Obviously, they're not asking me to write down the IUPAC name of butyl propanoate because that's how they asked the question. So they can't give me a mark for writing down butyl propanoate when they gave it to me. And again, ladies and gentlemen, the instruction said, using structural formula, do not get lazy and not write the structural formula of water. It is silly. All right. So 1, 2, 3, 4, 5, 6 is where those marks go. All right. Question 4.4 is one that we at PHA always try and include in our ester practical, purely because it does end up popping up on question papers all over the place. They want to know what is the function of the concentrated sulfuric acid that you add when you do esterification. I only put 3 carbon. Ha! Mrs. Tucker knows me well. She knows that some days I can't count. Thank you for fixing it. I really do appreciate it. There we go. All right. Thank you so much, guys. I really, on that point, I really don't mind if you guys see something, especially with a calculation, and you disagree with me, you correct me. I'm never going to take offense at that. We can all learn from each other. If you see something that you think, oh, hang on a second, could I maybe try it this way? Please ask. Like I say, we can all learn from each other. All right. Right, back to 4.4. What is the function of the sulfuric acid? I hope you guys all know that the easiest answer here is that it is a catalyst. Then what could we also say? We could say it is a dehydration agent, or it is used to dehydrate. But to be very, 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 very honest with you, I would stick with it acts as a catalyst. When would I not say it is a catalyst? When they say it in the question itself. All right, give the name of the functional group of bottle B, which is the same as the functional group of bottle A. Give the name. Name is the hydroxyl group. Hydroxyl group. There we go. Okay. Last one for the reactions on this page. Just take note that 4.6.4 is on the next page as well. Again, not to have a go at anyone's editing and formatting. Just need you guys, when you are busy with your question papers, to make sure you don't miss a question that is at the top of the next page. Okay. Bottle C is used to produce an alcohol. Alright, so bottle C, propene, 1, 2, 3. It doesn't matter where the double bond goes, because whether it's there or there, it's still propene. Okay. I start with an alkene, and I'm producing an alcohol, so it's a type of addition reaction. Name the reaction conditions required. Alright? Here again, guys, I know you generally don't like to memorize these, but what do we need to use to create an alcohol? We are hydrating. Okay? So we need to add water. I would argue that adding water would be a reactant rather than a reaction condition. So I would rather write that you are using a strong dilute acid catalyst. Obviously, when you have a strong dilute acid catalyst, good acid catalyst would be phosphoric acid. I always prefer using sulfuric acid because it's in so many different places within the organic reactions. So it's a nice, easy acid catalyst to remember. You can write any of them. And important just to say that it is dilute. Right, give the structural formula of the main product that forms and name the type of addition reaction. I'm quickly just going to do this one and then I'm going to draw the structure down here. Name of the type of addition reaction. I'm creating an alcohol. I'm adding water, which means I am hydrating. So it is a hydration reaction. Okay, so propene has got the 3 carbons. I started with those 2 hydrogens. I'm taking it from this little quick diagram that I drew. That hydrogen and these hydrogens. That is what I started with in black ink. Which means my alcohol has to go here somewhere. Markovnikov's rule says hydrogens are the life of the body. The hydrogen will go where there is already more hydrogens. So the hydrogen is going to go on the terminal or the primary carbon, and the hydroxyl group will then join on the secondary carbon. Why do I do it that way? Because they're asking major product. Don't forget that the other one around, the OH on the terminal carbon and the hydrogen on the secondary carbon, will still form, but it is not your primary product. It is a minor product. Okay, last question for question 4, and then we're going to go through all the multiple choice questions, and then if you add up, you will see you are almost halfway through your paper. Whoop, whoop. Right. 2 products form during this reaction. Okay? The products can be separated through distillation. Ladies and gentlemen, distillation is when you have your liquid in a possibly round bottom flask. You boil it so that the liquids in the flask start boiling. Obviously, if you have 2 different products, your products will have most likely 2 different boiling points. So what you do when you distillate is you boil at the lowest temperature, so you get the lowest temperature going, you have that liquid boil off, and then you distillate and you condensate it on the other side. So which property of compounds allows for distillation? You are looking at different boiling points. Alright. Cool beans. Right, let's have a look at the multiple choice questions for the organic. I hope that I can give you at least some indication of how to deal with some of these multiple choice questions. I often see guys lose silly marks for a lot of these. Some of them are straightforward and easy, and some of them you kind of have to go, okay, which answer could be right, and then you'll end up with 2, and then, you know, it's a little bit of a up and down, back and forth. All right, here we go. 1.1, which of the following compounds have a formal group? So you are looking for an aldehyde, which means you are looking for a name ending in al. So again, it might be classified as higher than level 2, but I honestly, you know, I really do think that this is a comprehension style question. So the answer here is D, propanol. Alright, correct IUPAC name. This is one of those situations where they're relatively mean and the longest chain starts right here at the top, and the straight chain is not the longest chain. Okay, so be very, very careful of this happening. Okay, so 2 colors. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Alright, so we are definitely looking at hexane, which means we have eliminated A and B. Okay. If I start here, then it's 1, 2, 3. If I start on this side, then it's 1, 1, 2, 3, 4. Okay. So my options here are, and it's probably these 2 options, is 1, 2, 3, 6 dichloro, and 3, 4 methyl, or 1, 4 dichloro, 3 methyl. Alright, so what I do in this situation, I add the numbers together. 3 plus 6 is 9, plus 4 is 13. 1 plus 4 is 5, plus 3 is 8. So, counting from left to right and up gives me a total of 8 on my substituents. We're counting from the right and down gives me a total of 13, which means 1,4-dichloro-3-methylhexane is the better answer. Alright, so we have a second one that has an answer of D. Paper 1 ended up being lots of C's, if I remember correctly. Okay. Alright, this is not a nice way of writing an alkane, but if you look here in the middle, can you see CH? It should have been CH2, CH2 if it was an alkane. So here, between these 2 carbons, there should be a double bond. I am adding a hydrohalide, so this is hydrohalogenation, and I'm getting compound P. Then with compound P, I add a strong dilute base. Okay? So here you can see this OH and that Br swapped places. So this is a substitution reaction. Okay? So compound X is an alcohol. I hope you guys can all agree with that. Ooh, sorry, go back. Did I miss an entire methyl group? Oh, my goodness, Gemma, I missed an entire methyl group. Okay. Here's this 3,4. Alright, hang on. Let's have a look here and here. I missed an entire methyl group. That is not unsurprising. Okay. So this 1, 4, then 3, 4 dimethyl. You guys are still on screen. Cool beans. Then 1, 2, 3, 4 dimethyl. Good catch, Gemma. Alright. Yep. So in this situation, you can see the 3,4 dimethyls are like the same. So I would focus here and try and get that combinations there the lowest. Very good catch, Jim. Okay. Right. Okay. Focus. I'm talking to me, not to any of you. I feel ridiculously tired after marking yesterday, but we've got this. Okay, here we go. So compound X here is an alcohol. That's what they want the name of. Now, unfortunately, and there might be some of you that could go through this entire process without having to write out compound P. I am not one of those people. So, if I look at this thing, and now what I'm going to do is I'm not going to write in all the hydrogens, okay? So I'm quickly drawing a diagram there of that there. Now I've got to add the hydrobromide. These two, it's not going to matter which goes where. So let's just say my hydrogen bromide went there. Okay? Now when compound P comes along, I am going to remove the bromine and add the hydroxyl group there where the bromine was. Okay, so they are looking for this thing's name. Okay, it cannot be B-but2-ene, that's an alcohol. It cannot be bromobutene, no, there. 2-bromobutane, can't be because I'm looking for an alcohol. Alright, so the answer here for 1.3 is A. Okay, that one ended up being a lot simpler than I actually originally thought it would. 1.4 is the last one of the organic chemistry multiple choice questions. So consider organic compound propanol aldehyde. Which one of the following is correct for the homologous series and the intermolecular force? Alright, so when you get two columns like this and it's a theoretical question, not a numerical question, I always try and close one of the columns and deal with one of the columns. It also sometimes works with numerical questions. So, aldehyde, ketone, aldehyde, alcohol. It is not a ketone and it is not an alcohol, which means I have eliminated B and I have eliminated D. Alright, now I go. Aldehydes have dipole-dipole forces, so it's not A because it hasn't got hydrogen bonds, so it is C. Okay, it sometimes really helps you when you start feeling a little bit overwhelmed with the multiple choice questions to try and eliminate options rather than just dealing with a whole table the whole time. Alright, cool. 5, 6, 7. Here we go. I know you guys have a joke. I don't get it. I'm not that current. I don't know. Anyway. Okay, so question 5, rates of reaction. Question 6, chemical equilibrium. And question 7, acids, bases. I do not recommend, if you are good at stoichiometry, that you leave them until last, especially the chemical equilibrium and the acids, bases. If you are not strong with those stoichiometry questions, then my recommendation is that you do the electrochemistry questions first. Okay, but that is something you have to decide for yourself. Okie dokie. Question 5, define the term heat of reaction. This is a grade 11 concept. Remember that especially in your September papers, you often get grade 11 type questions. And don't forget that at the end of grade 12, there is no reason for them not to give you any grade 10 or grade 11 work either. Okay, so heat of the reaction. It is the energy released or absorbed during a chemical reaction. Alright, heat of reaction, delta H. Okay, 5.2, reaction between sodium thiosulfate and hydrochloric acid is investigated. A conical flask is placed over a cross on a piece of paper. Over time, the time is measured from the moment the acid is added to the sodium thiosulfate until the cross disappears. A similar type question was in the 2020, I think, 3 grade 12 paper. They give you a balanced chemical reaction. How nice of them. And then what they do is they say that we are changing the concentration of this thiosulfate, and we are determining how long it takes until you can't see that cross. Why would you not be able to see the cross? Because a solid, a precipitate, is formed. I find it interesting that there is, for this question paper, 2 investigation type questions. I'm not saying you cannot get it. I am just saying that I find it interesting. And also in both questions, they're asking independent variable. Okay, so independent variable is the variable that I am deciding to change. Okay, so I am deciding to change the concentration of the sodium thiosulfate. So I'm changing the concentration of the sodium thiosulfate. Again, I would not write concentration. I would not, because you are not changing the concentration of the hydrochloric acid. The concentration of the hydrochloric acid is the same for all 3 these experiments or these investigations, so you have to be specific. Alright, calculate the average rate of reaction in moles per cubic decimeter, that's concentration, per second, there is the divide by time, for the highest concentration used. Alright. Does that question make sense for everybody? Okay. I hope that you guys can see that for this question, you need to also calculate x, so that x can go into delta t's place. Alright, I really do hope that you guys can see that. It's only a 3-mark question. So the question is going to be, but ma'am, how do we know? when all the thiosulfate is used up and forms sulfur. So you're simply going to use that concentration. You're going to say that this is the initial concentration and that the final concentration is going to be 0. Okay, so quite a bit of work to do on that one. We have to start, we have to start by calculating x first. So I have two thoughts here. This time here is relatively far out, so I would, different than the memo, say that my time is 31 plus 33 divided by 2. Why? Because 41 is relatively far out. So I would have my average time as 32 seconds. Okay. If you guys have a look at the memo in front of you, they disagree strongly with me. They believe that you should add all 3 times together. Oh, sorry, not divide by 2, divide by 3. And so, just double checking the memo. The memo gets 35 seconds. Right. I disagree vehemently with the memo. In a practical investigation, if something is relatively far out, like that 41 seconds is in this case, I would omit it. I would not use it in my final average calculation. So I'm going to show you guys how I'm going to use the 32 here. So please remember that rate is the change in concentration divided by the change in time. We are working with the change in concentration of reactants, and so the formula becomes minus. All right? So the final concentration is 0. The initial concentration was 0,8. They said use the highest concentration. And then I am going to use my average time, leaving out 41 seconds because it is such a vast outlier. And my calculator says the answer is 0,0025. So that is mole per cubic decimeter per second. I strongly would recommend that you rather write this using a scientific notation. So it would be times 10 to the power minus 3. But nothing forces you to. You could just leave it as 0,0025. Just don't round it to 0, guys. Jamie's asking, why am I using a negative? If I'm using reactants, then my final is always going to be smaller than my initial. So the top will always be a negative number. And within the scientific community, it was decided that a rate does not make sense when given as a negative value. And so when we are calculating rate of reaction and we are using reactants, we fix this negative number up here by putting a negative there. So when we are calculating the rate and we are dealing with reactants, then there is a negative in the calculation. If you forget that, then I always go rate is equal to change in concentration divided by change in time. And then I put my values in, And if my calculator gives me a negative answer, I add a negative in the formula as well as in front of my substitution. If, however, you are using the rate of products, then because products are formed, your final concentration or mass or whatever you are using for your rate will be bigger than your initial, and then there is no negative there because this rate is already a positive value. I hope that makes sense. Alright. So 5.2.3, give a reason for the disappearance of the cross. A solid is formed. Ladies and gentlemen, if bubbles form or there's a fizz, you are looking for the gas that is formed. When you can't see, or when things go milky, or like in this case, the cross is disappearing, you try and find the solid. Alright, so for 5.2.3, give a reason for the cross disappearing. A solid or a, now I can't remember the spelling. Give me a second. There we go. A precipitate is formed. Okay. Use collision theory and explain the trend. So use collision theory, not state collision theory. Use collision theory and explain why an increase in concentration decreases the time. Decreasing the time means that the rate increased as the concentration increased. Okay? I hope that's relatively within the theory that we already know and love. Okay? So, just like with the boiling points, there is quite a solid process that you can follow that will almost always guarantee you that you get all the marks. So the first thing you do is you make the statement, what is the independent variable, or what am I changing, what am I investigating. So in this case, as the concentration of sodium thiosulfate increased. Okay, starting sentence. Now you've got to go and talk about collision theory. Okay, so here is where your comprehension of your content comes in. Okay, so what happens if we have more concentration? We have a bigger number of particles. So the number of particles per unit volume increased. All right. First statement. Second statement, always true. Once you've said this, this is the argument. You then say the frequency, meaning number of per second, of effective collisions increased. Very important. The other way you can say it is the number of effective collisions per unit time increased. But I find it much easier to use the word frequency. The other word you guys tend to like to forget is the word effective collisions. Collisions could be increasing. Unless they're effective, rate of reaction is not increasing. Okay? And then lastly, this increases the rate of the reaction. So there's your third mark. Okay, use collision theory, explain why the rate of reaction increased as the concentration increased. Okay, and again, they decide to put question 5.3 on the next page. That's okay. Activation energy for this reaction is 27,3 kilojoules. Define the term activation energy and draw a sketch graph. That is quite a mean question, if I'm very honest with you. No, it's actually not. I find it an interesting question because I was expecting to see some or other weird catalyst with the graph thing, but it's fine. Okay, so activation energy. Minimum energy required for a reaction to take place. Minimum energy required to make a reaction happen. Alright, draw a fully labeled sketch diagram, meaning not to scale, of the potential energy graph for this reaction. Okay. Dum -dum. So 5.3.2. Looking for the previous page so that I can show you why I want to do something. Here we go. Okay. They tell me that this reaction has got a delta H, a heat of reaction that is positive. That means that this is a endothermic reaction, meaning that the reactants has a lower energy than the products. Okay, so delta H is over there. Okay, and my activation energy, which is equal to 27,3 kilojoules, is that one there. Okay, can you guys see my arrows start and end exactly where that value can be read off? Okay, I would also add axes, to be honest with you guys. So I like to use, oh sorry guys, that was almost very Afrikaans. Time on my x-axis and potential energy on my y-axis, and this is the thiosulfate 2H, and hydrochloric acid. And on this side I have sodium chloride. Sorry guys, there's a 2 missing over there. 2 sodium chloride plus water plus sulfur. There you go. Alright, so when they say fully labeled, we are also missing the activated complex. Here we go. Alright, now that I've got every single label in, the marking memo, strangely enough, only gives a mark for the correct shape, so the endothermic, and then 1 mark for the axes labeled, so the time and the potential energy, as well as the activation energy and delta H indicated. Okay, so a lot of my labels are irrelevant, but when you write the paper, you don't know that. Okay, so I would strongly hesitate to not also include every single label that I know normally should go into this graph. Okay, very quickly, the multiple choice question for rates of reaction. There's normally only one. Okay, I'm going to double check if there's 1 or 2. The graphs indicate the same amount Oh, it's a Maxwell-Boltzmann. Okay, sorry guys. The graphs illustrate the distribution of the same amount of 4 different types of oxygen gas samples. Each sample is at a different temperature. Which gas has the highest temperature? You are looking for the gas that has the peak, you hear my words, has the peak furthest to the right. The graph that has the peak furthest to the right. And now I'm very, very careful that you guys don't think that that happens to be here. Alright? If you look carefully at option B, you will notice that option B doesn't have a peak. Okay? Your answer here should be, in my opinion, C. Okay? However, no laughing. Memo says, accept all answers. I think that C is the correct answer, the better answer. Okay? But the memo clearly states that these 2 graphs were outside of the norm enough that they don't basically think it is a fair question. I would have scrapped the question. But I respect their memo. Alright, cool beans. Equilibrium. Here we go, here we go, here we go. Question 6. Good. You have a chemical equation. Chromate plus hydrogen gives me dichromate and water. What is meant by a chemical equilibrium? Ladies and gentlemen, there's a couple of keywords that they're looking for. You have to say it is a dynamic equilibrium. And you have to say that the rate of the forward reaction is equal to the rate of the reverse reaction. It's not where the forward reaction is equal to the reverse reaction. No, no, no. It is when the forward reaction and the reverse reaction are happening at the same rates. Okie dokie. Next up, using Le Chatelier's principle, explain how an increase in temperature will change the color of the solution. Okay, first of all, this has got a delta H of negative value, which means this reaction is exothermic. We are talking about an increase in temperature. An increase in temperature will favor the reverse reaction. An increase in temperature favors the endothermic reaction. If this reaction is exothermic, an increase in temperature will favor the reverse reaction because the reverse reaction is endothermic. Okay. Sure, here we go. 6.1.2. So I always start by saying that an increase in temp temperature favors the endothermic reaction. Fact. Okay? Not conjecture. Fact. Something you can memorize. Okay. Then I would say the forward reaction is exothermic. For this one, again, why? Delta H is negative. Therefore, an increase in temperature favors the reverse reaction. Okay, now, I didn't answer the question yet. They said, using Le Chatelier's principle, explain how an increase in temperature will change the color of the solution. So, the solution will become more yellow. Therefore, the solution will become more yellow. Okie dokie. A concentrated solution of hydrochloric acid is added to the equilibrium mixture. I hope you guys can all see that what they are trying to get at is the hydrochloric acid is increasing the concentration of the reactants. Okay. What effect on the concentration of dichromate ions? What is the effect of the dichromate ions and hence the color of the solution? Write only increase, decrease, or remains the same and explain your answer. Ladies and gentlemen, if you add more reactants, the reaction will rebel against you by creating more products. So more orange, more dichromate will be produced. Okay? So the answer here is that it will increase the dichromate concentration for 3 marks. That means 1 mark goes for the word increase. Alright. And then 2 marks going for Y. So, increasing the concentration of reactants, because that's what we did. We added acid. Acid in this example is a reactant, so I'm increasing the concentrations of the reactants. Will favor the forward reaction. Producing more Cr2O7 2 minus or minus 2 ions, turning the solution orange. I hope I spelled orange correctly. It's been a day. Okay, so increasing the concentration of the reactants favors the forward reaction, which will turn the reaction orange. So 1 mark goes for turning orange, 1 mark goes for increasing the concentration, will favor the forward reaction, and there was 1 mark for saying that the dichromate ions increase. Okay. New reaction. Carbon monoxide forms carbon dioxide and carbon. In a 1 cubic decimeter container, so that's the volume of the container, we have a temperature, we have carbon dioxide and carbon gas. An excess of solid carbon is formed. The concentration of carbon monoxide is 1,10 times 10 to the power minus 2 moles per cubic decimeter, and the concentration of carbon dioxide is 1,21 times 10 to the power minus 3 moles per cubic decimeter. Is the system in equilibrium? I'm just double checking. Temperature, calculate moles. Okay. This oak here, with that 7 marks, that is definitely our big KC. Okay. But the fact that they're asking about equilibrium, they gave a KC value and they gave me all the concentrations, means we're going to do KC here. I think we are going to take, hang on, it is 10 past 5 according to the watch above me. If your watch is different, I'm sorry. Everybody, we're going to take a, let's call it 7-minute break, because that's how long I need to quickly refill my cup of coffee. Alright, if you want to try these two on your own, both of these two are going to be KC. Okay, I'm just going to pause. I'm going to leave this up here, right? And I'm going to mute myself so that you can try it. That's why I'm giving a slightly longer break. So I will see you guys back here in about 7 minutes. Okay, and then we will carry on with the KC and acids and bases and those. I know it's been a long day. I'm also feeling it. So let's maybe give ourselves a bit of a break. Okay, I will see you guys back here at 7 minutes. Let's make it 20 past 5. Okay, I'll see you guys back here at 20 past 5. Alright guys, I'm going to do 2.1 and 2.2 quite slowly while we give everybody a chance to come back into focus. Thank you for the break as well. I had a cup of coffee quick. Really appreciate it. Alright, so we are going to do 6.2 and 6.3. Oh my goodness, the puppies are shouting at me. 6.2.1 and 6.2.2 all together. Alright, so 6.2.1 is the system in equilibrium. So I just want to warn you guys that, and everybody listen to what I am saying, you cannot start your Kc value equation with the concentration of products divided by the concentration of reactants. You cannot. Then they stop marking. Alright? So you have to start it with the concentration of the products, which in this case is just carbon dioxide. Why is it just carbon dioxide? Because carbon is a solid. Divide by the concentration of the reactants, and don't forget to add the stoichiometric ratio as an exponent. Okay, so now what I'm going to do is I'm going to add the concentrations in that they gave me. They said the concentration of carbon dioxide is 1,21 times 10 to the power minus 3. And the concentration of the carbon monoxide is 1,10 times 10 to the power minus 2. But of course it is to the power 2. Alright, let's plug that into a calculator. 1,21 to the power minus 3 and 1,10. I don't know why I put the 0 in there, but hey, squared. Okay, and we get 10. Alright, and this is equal to the Kc at 1095 Kelvin. What does that mean? Therefore, the reaction is in equilibrium. Alright. Quite an interesting way of asking it. I actually quite like that way of thinking about it. It's quite cool. Okay. 6.2.2. Carbon dioxide gas is added. The mixture reaches a new equilibrium. The equilibrium concentrations of carbon monoxide and carbon dioxide are now equal. The temperature remains constant. Calculate the amount of carbon dioxide that was added to the system. Okay, so this is quite a big Kc equation. I like to use a rice table. Some people call it a mice table. Ratio, initial concentration, change in concentration, and final concentration. So, let me just get my bearings. Okay, so I like to write the equation at the top. So my 2 carbon dioxide gas in equilibrium with my 2 carbon monoxide gas in equilibrium with carbon dioxide gas and carbon as a solid. Okay? Hi Crystal, if I need to go back and explain it to you, just let me know. I really don't mind. Alright, now I, as you guys might have noticed, sometimes work faster than I should, which means I've had to build in fail safes for myself in things like KC tables. So what I do is right under the equilibrium sign, I do a double line, which means I know that the sign on this side of the double line and the sign on that side of the double line is different. And then I also know that my carbon is not going to play a role in my Kc value because it is a solid. So the ratio here is 2 to 1. Okay. My initial is what I started with before I added the carbon dioxide. So I had 1,1 times 10 to the power minus 2 moles. Why am I saying moles? Because I had a concentration of 1,1 times 10 to the power minus 2 in a container that has a volume of 1 cubic decimeter. Then I had 1,21 times 10 to the power minus 3 moles of carbon dioxide. Okay. Then there has been a change. Okay. Give me a second. I can see some of you know this is going to happen. Don't panic. And then at equilibrium, they had the same concentration, the same number of moles, okay? Which means, I know, I'm sorry, we're just going to say that the concentration at equilibrium was X. Alright, now, if we read the question again, if I can get my pause on it, I added carbon dioxide gas. So initially I had that, and then I added carbon dioxide gas, right? I can't use X because I've got X over there, so I added Y. Alright, now I can go and calculate what the concentrations were from my Kc equation. Why? Because the temperature remained constant, I know what the Kc is, okay? So I can say the Kc, again, concentration of carbon dioxide divide by the concentration of carbon monoxide squared, and that is equal to 10. And then I can say X divided by X squared is 10. Alright? Lots of math involved, so X is equal to 10x squared. So 10x is equal to 1. I hope you guys see how I got that. Grade 10 math. Alright. And so x is equal to 1 over 10, which better put 0, 1. Right. So instead of using x here, we're going to say it is 0, 1 moles. Alright. Now, the change is how did we get from there to there? Because ultimately, there's where we're going. Alright? You can use plus or minus. It's not going to make a difference. Okay? I would use this one here. I hope you guys can see that. And say that 1, 1 times 10 to the power minus 2 plus, Now we need another unknown. Z, A, B, I don't know, pick one, is equal to 0, 1. And now solve for that unknown. Okay, so this one goes over. So the change is going to be 0, 1 minus 1, 1 times 10 to the power minus 2. 0, 1 minus 1, 1 exponent minus 2. So 0, 0.089. It's a positive value. So what effectively happened is the carbon monoxide increased by 0.089, which means the carbon monoxide would decrease, be careful, ratio by half that. So I used my Kc equation to determine the number of moles of carbon monoxide and carbon dioxide at equilibrium. They told me in the question that they are the same. Then I used the carbon monoxide. I have the initial number of moles and the final number of moles, and I use that to work out by how much it changed. I used that to determine by how much the carbon dioxide would have changed. Ran out of page. Those of you who know me well know that I cannot plan a page at all. So I'm now going to use this side to solve for how many moles of carbon dioxide did I add after this thing was in equilibrium to create this new equilibrium. So I'm going to say 1,21 times 10 to the power minus 3 plus y. This is the initial number of moles minus 0,089 over 2. The change is equal to 0,1. And now it's actually simple math. I know it didn't start out being simple math, right? So we're going to say y is equal to 0,1 plus 0,089 over 2. Okay, dealt with that part. I'm going to take that over, minus 1,21 times 10 to the power minus 3. Those of you who are not every day in my class, you will know, you won't know, but I'm going to inform you. My ability to use a calculator is often very suspect. So if I have the ability of only plugging things into my calculator once, I take it. There we go. So y is equal to 0,14329. You can either leave it like that, or you can round it to a minimum of 2 decimal places. Was added. Right, guys, that is a seriously tough KC. I think they more than make up for the easy KC at the beginning of the question. Okay? It's a tough KC question. It really is. Please don't for a second think that I think that this is just an easy KC. Alright, there's so many parts of this. Okay. Oh, puppy's upset. Sorry for them, guys, but you know, they protect the house. Alright. Multiple choice. Here we go. We have a chemical reaction, gas, gas, gas. And it is an exothermic reaction. Sorry guys, I'm just trying to get the puppies to be quieter. Sorry guys, they're very vocal. Alright, we have a chemical equation. It is an equilibrium equation. It is an exothermic equation. Gas, gas, and gas. Alright. Change was applied to the equilibrium of the mixture. I'm assuming there's a there's a temperature change and there's a concentration change. Identify the changes that best describe the graph. Okay, so firstly, it is an exothermic reaction. When we change the temperature, the concentration of the products decreased, which means that the reverse reaction was favored during that temperature change. The endothermic reaction was favored, which means the temperature was increased. I'm going to say that again. When we change the temperature, the concentration of the products decreased. That means that the temperature change favored the reverse reaction. The forward reaction is exothermic, which means the reverse reaction is endothermic, which means I increased the temperature, which means it cannot be A and it cannot be B. Okay, now I've got to figure out, did I increase during my concentration change, did I increase something or did I decrease something else? And now this graph and that little spike there makes life so nice. Okay, it is very clear to see that during this concentration change, the concentration of the nitrogen monoxide went down significantly before everything else reacted. Okay, so it's very clear that I decreased the concentration of the nitrogen monoxide, which means the only possible answer here is D. Alright, acids and bases. One of my favorite questions, purely because I really like stoichiometry. I know many people don't. I know many of you might be slightly worried about it, but I'm going to be honest. I absolutely enjoy stoichiometry and stoichiometric calculations. I could do them all day, every day. Alright, so these are questions that I truly enjoy doing. Right, so the pH of solution X is measured before and after adding 10 drops of sodium hydroxide. Initial pH 7, neutral. Final pH 12, which makes sense because I'm adding sodium hydroxide, right? So we are hoping that the pH decreases, otherwise I don't quite know what we are doing. Right. A concentrated sodium hydroxide solution. Ladies and gentlemen, that's quite an interesting question, right? Often they ask about what is meant by strong and dilute, or strong and weak, or what is meant by a standard solution. This is a little bit of a different one. So if you remember, concentration, this is not the answer, this is the thinking. Concentration is number of moles of solute divided by volume of solution. Concentrated means that there is a large number of moles of solute in a smaller volume of solution. Right, so I would say large number of particles of solute in a smaller volume of solution. Instead of saying in a smaller volume of solution, you could of course use the words per unit volume. Right. Then what happens to the concentration of the hydronium ions? So if the final pH decreases, it means we are going more basic, which means that the hydronium ions had to decrease. Explain, answer in terms of the ionization constant Kw of water. Okay, so I would say that the concentration of the OH ions, the hydroxide ions, increase, and Kw is equal to H3O plus times the concentration of the hydroxide ions, and it is 1 times 10 to the power minus 14. It is a constant value. Alright, so 1 mark for decrease, 1 mark for saying that the hydroxide ions are increasing, and 1 mark for referring to the fact that Kw remains constant. Calculate the concentration of the OH minus ions, the hydroxide ions, in the final solution. You can see how they led us to that Kw and pH calculation. Alright, so pH is equal to minus log of the hydronium, and we know that the pH is equal to 12. Right, now you'll remember that the inverse of log is 10 to the power of. That means that to calculate the concentration of the hydronium ions, you are going to put into your calculator 10 to the power minus 12. Right, now I would leave that value as is because that is a whole number, so I wouldn't touch that right now. Now I would remind myself that Kw is equal to the concentration of the hydroxide times the concentration of the hydronium, and that remains constant from the information table as 1 times 10 to the power minus 14. I just worked out that concentration, so hydroxide concentration times 10 times 10 to the power, 10 to the power minus 12 is equal to 1 times 10 to the power minus 14. I often have to shout at my stronger math students. I say shout meaning like have a go at them, you know what I mean, about when they see this thing happening or when they see that thing happening, about actually showing the substitutions. Sometimes when an answer is as obvious as this is, you guys sometimes forget to show all the substitutions and then you lose silly marks about it. And the other problem is that a lot of people that are very strong with math, especially exponents, will see that this concentration is 10 to the power minus 2. You guys kind of see that minus 2 happening. And then what you forget further than that is that you still need to write a unit with your answer. Okay, so that's two very, very big pitfalls that you could possibly, if you are not careful, fall into in this question. It's not a hard pH calculation. I actually think it's really nice and easy. I think it's very fair. Just be careful that you guys don't trip yourselves up because you see things happen and you forget about the process that actually gets you the marks. Okay. 7.2 is a completely separate acids and bases calculation. The learner titrates a sodium hydroxide solution with a standard hydrochloric solution with a concentration of 0,0958 moles per cubic decimeter with a balanced chemical equation. So they're using 20 cubic centimeters of sodium hydroxide, and then they are adding hydrochloric acid. If I look at these values to me show a very clear no outlier, right? So these values, you're either going a little bit up, a little bit down, but I think these values are all beautifully within range, right? So when they now ask for 7.2.1 to calculate the average volume, I am comfortable using all three these values. I was not comfortable using all three the values in the previous example because I really firmly do believe that there are outliers in that. So here I am very comfortable in telling you that the 20,5, the 20,05, the 20,15 and the 20,10, all those values to me fall solidly within a decent average. I see no reason why any of those values cannot be used. They are not outliers. Obviously, if you math strong, then you don't have to use a calculator at this point. I'm just going to double check myself and not just trust my gut feel. Divide by 3. Yeah. Okay. So 220,1. That is the exact value that my calculator gives. So you could write 20,10. Nothing stops you from doing that. But I honestly don't think that they could penalize you because that is the exact value as given by your calculator. Alright. Now, this way of wording questions often trips you guys up, even though we're trying to get you to an easier answer. But anyway, prove with calculation that the initial concentration of the sodium hydroxide solution was 0,0963 moles. Alright, now when I say it trips you up, you guys often think that you can stop the question halfway through because I've given you the answer. The reason why we gave you the answer is probably because you have to use it later on. Alright, so you would approach this in the same way as if I asked you to calculate the initial concentration of the sodium hydroxide. Now, with this question, you have two options, two roads to go down. From your information page, you have this titration formula, or you could simply use C is equal to N over V, C is equal to N over V. In this situation, because the reaction has got this 1-to-1 reaction ratio here, I strongly would recommend that you use this titration and 1/1 there. Alright, I don't always recommend it, especially for younger learners when they're starting to figure out how to use all the stoichiometric questions and formulas and stuff. I don't often recommend this. Okay, so C of the concentration of the acid times the volume of the acid divide by the concentration of the base times the volume of the base is equal to the mole ratio of the acid divide by the mole ratio of the base. of course, you could swap the two around. Okay, now they are asking you to prove the concentration of the sodium hydroxide. So you are not going to sub in the concentration of the sodium hydroxide. You are going to sub in the concentration of the hydrochloric acid. It was given right in the beginning. You just worked out the average volume of hydrochloric acid that you used. So obviously it's going to be positive marking from there. You are asked to show a concentration of the base, and up in the question they say that you're using 20 cubic centimeters of the base. Now, because that and that unit is the same unit, and that unit is the same unit, you can get away with doing that. I strongly recommend against it. Alright? I strongly recommend that rather than use just the cubic centimeters, you divide both by 1,000. Can you see why it doesn't matter that you both have cubic centimeters? Because that divide by 1,000 and that divide by 1,000 cancel each other out. I just want to point out to you that you do have to be careful in general of which units you use. And then of course it's a 1-to-1 ratio. You just have that guy over there. Now, you are welcome at this point to obviously plug this into your calculator. But because we have given you the answer, you will not get a mark for writing down the answer, right? You will get a mark for using the formula, and you will get 1 or more marks for your substitutions. I'm quickly going to check the memo. Right, so the memo says this substitution at the top, this ratio at the bottom, the formula mark, and that value there. That's where the 4 marks go. No mark for the final answer. Alright, so you can plug all of this into your calculator, but because they gave you that answer, I'm going to be very honest with you, I wouldn't bother. Alright, cool beans. Last one, and we know it's a doozy. Why? Because it's acids and bases. The standard sodium hydroxide solution, that one, hang on, that one, is used to determine the percentage mass of phosphoric acid in a commercial brand of rust remover. Analytical chemistry, yay! 10 grams sample of the rust remover is weighed and transferred into a volumetric flask. It is filled with distilled water. 10 cubic centimeters of that solution is titrated with 24,445 cubic centimeters of this sodium hydroxide. And they give us a balanced chemical equation. Calculate the percentage mass. Of course they did. Of course they did. Okay. Whenever I am doing quite intricate acid-base reactions, for myself, I write down just that baby bit of the reaction. Okay? You generally don't need the products. Then I know that I am using 24,45 cubic centimeters of a 0,0963 mole per cubic decimeter concentration. Okay, so what I'm going to do is I am instantly going to take that to moles, and now you do have to watch your units. Okay, so 0,0963 number of moles divide by 0,0245. Okay, so it's a multiplication to get moles on its own. 0,0963 times 0,02445. Right, calculator says 0,002354 and change. Right, I'm writing more decimals down than needed because I really don't feel like having my answer be out just because the decimals are so far away. Alright, so that was my first step. Second step is to use the mole ratios. Alright, if in doubt, anything to moles, mole ratio. It's a 3:1 ratio, right? I know that I use 0,002 and change of sodium hydroxide. I hope you guys can all see that I'm dividing that value by 3. So I take my answer that I had in the previous question, divide it by 3, and I get that there was 0,000. See, this is why you write more decimals than you need, because somewhere along the line, if you're not careful, rounding will create a situation where your final answer is very far out. Okay. Now, this was in the 10 cubic centimeters. Okay? We agree? So in 250 cubic centimeters, there would be 25 times as much. So 0,0007848, oh my goodness, times 25. Why? Because this was in 10 cubic centimeters, but originally the 10 gram sample I put in 250 cubic centimeters, which means in my original sample there was 0,019, and again, when my decimals get so small, I always worry if I don't write enough decimals, and I try and leave the answer in my calculator as far as possible. Okay, so this was mole of phosphoric acid in the 10 gram sample. All right, let's take that mole to mass so we see how much of that 10 gram sample was actual phosphoric acid. So I'm going to use trusty old faithful, mass divide by molar mass, and I'm not clearing my calculator, I'm leaving that horrible decimal right there. Right, phosphoric acid, 3 hydrogens. I haven't seen a periodic table all day. So phosphor is 31 and oxygen times 4. So mass is going to be this thing times that horrible decimal. So into my calculator goes times, and then I'm plugging all of that in. Right, so I get 1,92287 and change. Alright, so this is the mass of phosphoric acid in the 10 gram sample. The question is, calculate the percentage by mass of phosphoric acid in this original sample. So 1,922 etc. and change, divide by 10 times 100. Gives me 19, and now I'm rounding, 0.23%. Alright, I know you guys typically don't like these. The only way to get better at these is to practice. Alright, quick look at the multiple choice for this, and then I'm going to do both electrochemistry questions at the same time, purely because those electrochemistry questions often like each other, and it means that we can keep our brain on that last little bit of the theory. Alright, so multiple choice question. Which one of the following statements of water is true? It is a weak electrolyte that undergoes autoionization. That one should jump out at you. The equilibrium constant for ionization of water at room temperature is that? Definitely. It ionizes completely at room temperature. Is that true? Crystal, why did we divide by 10? For the previous one, the reason why I divided by 10 is because the original sample was 10 grams of the original sample. Yes. Alright. Ionizers of water produces twice as many hydronium ions as hydroxide ions. Not true. Alright, so the only iffy ones here is 1 and 3. Okay. And 1 and 3 cannot be true at the same time. Because if something is a weak electrolyte, there is no way it ionizes completely. Right? Do we agree? And this might be true for pH equals 0 for water. However, the fact that the hydronium concentration and the hydroxide concentration of water is the same is not linked to the fact that it ionizes completely. That's not quite the point there. Okay? So 3 is not true, but 1, weak electrolyte, and that autoionization is what gave it away there. Alright, so the correct answer for 1.7 is A. I knew it couldn't be C because 2 is definitely true. So I knew it was either going to be A, B, or D, because A, B, and D both have that 2 in it. Alright? I also knew that it's definitely not 4, which means it definitely cannot be D. Alright? So I eliminated C and D quite quickly. Then I was kind of but that autoionization there really strongly pulled me towards the fact that number 1 is also true, or I, and therefore A is the correct answer. Okay, so that is the bulk of the paper, ladies and gentlemen. I think we are winning, slowly but surely. Right, electrochem, last 2 questions. A learner was asked to build a galvanic cell. They had a magnesium rod, a copper rod. Okay, so one of those is the anode and one of those is the cathode. Do we need to memorize the value in number 2 for water? No. kW is given on the information page. Crystal, I'm going to pull it up here. There's kW. So the concentration of the hydronium ions times the concentration of the hydroxide ions. kW, 1 times 10 to the power minus 14 at 25 degrees Celsius. And I haven't seen them not do 25 degrees Celsius, okay? Obviously, if we change the temperature, then the Kc, which in this case is Kw, changes. All right. So, we have a sodium carbonate solution, we have a magnesium sulfate solution, and we have a copper sulfate solution. Now, ladies and gentlemen, if we have a magnesium rod, we need to use the magnesium sulfate with the magnesium rod. And, oh no, we're using blue. If we have a copper rod, that means that that copper sulfate solution is going to go with the copper rod. Which means the sodium carbonate solution is going to go into the salt bridge. Right. They give us a partially labeled diagram. If the electrons move, 8.1, pardon me, if the electrons move from left to right, label all of them. All right, so let's just think. It's moving from left to right, okay? So oxidation, reduction, which means anode and cathode. All right. Now, verbally, linguistically, I think is a better way of putting it. I do have a slight issue with the way in which they worded this using label, right? Because it's not 100% clear that they want you to put these in here. Alright. But if you have a question like that, you can always write both. So one is the anode, and that will be the whatever rod. Okay, so how do we do this? We need to go to table 4B. I like table 4B way more than I like table 4A, right? Don't call me biased. It just is. I have a good relationship with table 4B. I understand how it works, and I can use table 4B more effectively to explain to you guys how this thing puts together. So, for oxidation, we are looking for the substance that is furthest to the top on the right. Okay? Oxidation. And then for reduction, we are looking for the substance given to us that is lowest down on the left. So the first thing you have to do anyway is to go find the magnesium half reaction as well as the copper 2+ half reaction. There we go. Alright. So I'm just going, there we go. We got them in. Remember, you get this table. You do not have to memorize it. The only thing you need to be careful of is that you get 4A and 4B. Alright, so that means, ladies and gentlemen, that magnesium is going to be the anode, and magnesium is going to be oxidized to magnesium 2+, and that copper 2+ is going to be reduced to copper metal, and that copper will therefore be our cathode. Top on the right is the thing that gets oxidized, bottom left is the thing that gets reduced. It goes in a C. Alright. That means, if we take our picture, 1 is our magnesium rod, 3 is going to be our magnesium sulfate solution. 2 is going to be our copper rod, and 4 is going to be our copper sulfate solution. Right, it's 4 marks because it's 4 things you have to write down. Okay, write down the equation for the half reaction taking place at the cathode. And now, because I've already gone to table 4b, this is pretty simple. Cathode is reduction, and so my reduction half reaction is copper 2 plus 2 electrons gives me copper metal. You do not have to write the phase symbols. However, you may not write the double arrow. If you write the double arrow, it's 1 out of 2, right? And you must write it in the direction that it is happening. All right, calculate the initial EMF under standard conditions. Okay, nice and easy. Trying to find a page. Here we go. All right, so on our formula page, there are 3 formulas. They are the same 3 formulas. That one, that one, that one are the same 3 formulas. I prefer the middle one because I generally think in terms of reduction and oxidation, but I'm equally comfortable with cathode anode. There are some of you weird people, and I love you dearly, but still, that like the oxidation reducing agent one. My brain struggles to flip the 2 around, so I tend to use the potential of the cell is equal to the potential of the reduction reaction minus the cell potential of the oxidation reaction. Okay, now reduction, come on table, is plus, you don't have to write the plus, 0.34 for the copper 2 plus, minus, because it's in the formula, the reduction reaction is minus 2.36. Now into your calculator, obviously you just put the plus in, right? But when you write it down, you must write the value as they appear on the table. And the answer here is 2.7 volts. Alright, the reason why it is such a heavy marked question is because it's formula, sub, answer. And if you don't put that negative in there, they don't give you the sub mark. Alright, please don't do that just because you are lazy. Right, the function of the salt bridge, there are many, right? I like the statement that the salt bridge maintains ion neutrality, but you could also just say that it completes the circuit. Alright, then typical ear galvanic cell question. How will the following affect the EMF? Increase, decrease remains the same. So the area of the copper rod, I don't know if any of you have dealt with that type of question, but I hope that most of you would recognize that nowhere in our conversations that we've had we have spoken about the electrodes, the actual electrodes, other than to say that they get the anode, yes, the anode gets reacts and therefore gets used up, basically it decreases. So the area of the copper is going to make no difference. remain the same. Right, now the question is, how will the concentration of the magnesium affect where we are at? Okay, so during this reaction, magnesium becomes magnesium 2+. So even though we start with a 1 mole per cubic decimeter solution, as the reaction happens, magnesium being oxidized increases the concentration of this solution. So when we increase the concentration of the magnesium ions, we are taking the reaction closer to equilibrium, which means we are decreasing the effect. Well, we are taking the cell closer to equilibrium, which means the cell is becoming closer to being flat, in inverted commas, which means we're decreasing the EMF. Alright guys, last question for the long questions. Oh my goodness, we're almost there. Okay, define the term electrolyte. Not a definition we see that often, but it is a substance, alright, whose aqueous solution contains ions. Alright, so if I take a substance and I dissolve it in water, that solution contains ions. Alright, name a suitable solution that can be used for electrolyte in this process. So let's look at what we're doing. Impure copper is refined. So in our electrolyte, we need copper ions. The easiest one is the one we often use, copper sulfate. But you can use any copper. Now, the question states name. So you cannot write the formula. You have to give the name. Like I say, I tend to use copper sulfate, but copper chloride could work, any copper solution. Alright. Write down the equation for the half reaction that happens at the anode. Remember, anode is still oxidation. So anode is still oxidation. It is still where a loss of electrons occur. We are purifying copper. And so in this whole cell, over and over and over again, copper is going to become copper 2+, and copper 2+ is going to become copper. Remember, that's how we refine. We pull everything off and then we shove everything back on. Alright, a precious metal such as silver, there's a couple of them, which is usually part of the impure anode, sinks to the bottom of the cell. Alright, we call this the sludge. I hope you guys remember that. Explain this observation by referring to the relative strength of the reducing agents. Okay, so silver sinks to the bottom because it is not oxidized, which means silver is a weaker reducing agent than copper. Alright, so silver is a weaker. Why reducing agent? Because they say I refer to reducing agent. Reducing agent than copper. And don't ask me why, but that is always 2 marks. Silver, weaker reducing agent than copper. That's 2 marks. Alright? Which means, therefore, silver will not be oxidized. Alright. Now, this question I absolutely love. It is where we combine the idea of current and moles and all sorts of goodiness. Makes me super happy. It is a harder question, right? They have asked them several times before. Alright, so after 10 minutes, so delta T is 10 minutes. I hope everybody's jumping up and down, shouting at me to convert minutes to seconds. All right. 1,6 grams of copper is created. All right. Calculate the number of electrons that flowed through this circuit. All right. Calculate the number of electrons that flow through this circuit. I think they've simplified that question a little bit from how it is often asked. Okay. So we're going to go mass of copper to moles of copper. First things first. So 1,6 divided by copper is 63,5. Yeah, doubting myself today. Almost there, guys. 1,6 divided by 63,5. 0,0251. Oh, now it's getting ugly. Yeah. I'm obviously just not clearing my calculator, but you know, let's write down. Then you guys need to remember that now you have to go from moles to number of particles. All right, that's the trick with this question, because each atom, each ion gains a certain amount of electrons. That is the trick with this question. All right. Again, I'm not clearing my calculator. 6,02 exponent 23. Right, calculator says 1,51685 and change times 10 to the power 22 copper atoms. Now, important to remember that each atom equals 2 electrons, right? Each atom that gets created requires 2 electrons to be created. So I need to take that 1,5 and multiply it by 2. Therefore, 3,033 and change times 22 electrons. Okay. And that's the answer they want. Nowhere did we need to use delta T. If they asked you for the current that would be required, then you would use delta T. Alright guys, we're so almost there. 3 multiple choice questions and then we're there. Come on, we can do this. I know you guys are tired. You have been epically amazing today, right? I know that especially those of you who wrote paper 1 on Friday, you are starting to become super tired. Okay, I get it. We're almost there. Alright. Oh, here's an acid-base question. Sorry about that. Normally... Okay, never mind. Okay, a laboratory assistant prepares a solution of nitrous acid and hydrogen cyanide. Ooh, fun stuff. Ka values. Alright, remember, Ka value is basically a Kc for the acid. So the bigger the Ka value, the stronger the acid. Okay? And the stronger the acid, the lower the pH. Oh my goodness. Okay, so Ka bigger, therefore stronger acid. Okay? And stronger acid equals smaller pH. What a mean question. What a mean question. All right. So the stronger acid is the one with the bigger Ka value, which is for nitrous acid, right, which comes part of acid rain, I suppose. All right. But if nitrous acid is the stronger acid, it means it has the smaller pH. So the answer is B. Alright, last two guys, come on, we're so almost there. Calcium metal reacts quickly in hot water to produce calcium hydroxide, which is the reducing agent, which is the oxidizing agent. Okay, so calcium goes from calcium solid to calcium 2+. So 0 plus 2, which means calcium lost electrons, which means calcium was oxidized, which means calcium is our reducing agent. I'm going to say that again. Calcium lost electrons, which means calcium was oxidized, meaning calcium is our reducing agent. Okay? Calcium hydroxide is a product. Therefore, calcium hydroxide cannot be the oxidizing agent. Alright. Only reactants can be agents. So the answer for 1.9 is C. Last one, guys. Come on, we got this. We have half reactions and potentials. And now we are asked for the strongest reducing agent. Alright. So, because these are all hypotheticals, it's not even going to help us to go anywhere near our table. Okay? If we hypothetically look at the table, right, we are looking for the stronger reducing agent. So we are looking for the thing that goes further up to the further up to the right. Alright. Can you guys see on table 4B, the E0s get less and less and less. Okay, I hope you guys can see that as it becomes a stronger reducing agent, the E0, the standard potentials, get less. Okay, so can you guys see? There we have that. There we have those. No? See that? Okay. So the anomalies are those two. Can you guys see how these E cells, this one is biggest, I would have put that one over there, and that one is the smallest, well, the bigger negative. I hope you guys can see that. Okay, see that? If we switch this reaction that way, we would get negative 0.11, right? Which means these two guys are weaker oxidizing agents and reducing agents, which means our anomaly here is that oak over there. I hope you guys can see that. Okay, so the answer here is D. You could, of course, go work them all out, hypothetically, if you wanted to, right? But I would swap things back and forth and go, okay, what's getting bigger, what's getting smaller? Alright, ladies and gentlemen, that brings us to the end of this prep session. Thank you so much for bearing with me for, 3.5 hours. Well done. I know we took a bit of a break. If you go through the video, you are welcome to still leave comments. I will leave them open, right? And then end of tomorrow, let's call it 5 o'clock, I will check in on this video and answer any questions that is left in the comment section. Right? Obviously, you're welcome to share this video with anyone. And then I hope you guys have a good day. I hope you guys write well on Monday. And then I hope you have all the best for the last little bit of the exam session. Alright, thank you so much for joining me. I will chat to you guys in the next one, and we can do this again. It actually works quite nicely. I'll just learn how to deal with the chat being ever so slightly slower. Alright guys, thank you very much. Have a